Hi guys, it's Professor Bittner. I am making a quick tutorial on how to deal with some of those probability problems that are in your homework. And I've given you a problem that's kind of similar to the one you have, but I just want to work through it and discuss some of the ins and outs of something like this, because there's a few things you just have to recognize in this kind of problem. All right, two normal parents have a son with cystic fibrosis, a recessive disorder. Of course, cystic fibrosis is a phenotype, but when they tell you that it's recessive disorder, they're telling you that the allele for cystic fibrosis is on the recessive allele and that the normal allele is the dominant, right? And so if the parents are normal, that means normal phenotype. But in order to have a son with a homozygous recessive genotype, then those parents would both have to be what we call carriers or heterozygous. So when they give you a statement like this, when they tell you something that's already happened, they're doing it in order to help clarify the genotype of the parents. Okay, because two normal parents could both be homozygous for the dominant normal allele, or one could be homozygous and one could be heterozygous. But in this case, they're helping you to know that both parents are heterozygous so that you can solve this problem. Because if you didn't know that, you wouldn't be able to go any further. So these are the parents, heterozygous, and we're going to say the big A is the normal allele, normal, and the little a is the cystic fibrosis. Little a is CF. Okay. For example, it doesn't matter, whatever it is. Okay. They decide to have more children. Now that first child is already born. So here's something to think about. They're not asking you what the probability of having that first child would be, because that child's already born. Any child who's already, any event that's already happened has a probability of 100%. So two normal parents have a son with cystic fibrosis. What's the probability that their first child would be a son with cystic fibrosis? 100%, because that child's already been born. All right, so that part is not an unknown. But then it says they decide to have more children. What's the probability that anything after this is going to be the unknown? That their next child will be, or actually I would say the will be is kind of a key. What's the probability that their next child will be a son with cystic fibrosis, comma, followed by a third child that is a normal daughter? All right, so child 1 is a son, I'm going to use the gender symbol, with cystic fibrosis. That's 100% certain. But they're saying, what's the probability that in position 2 of the birth order, this child would be a son with cystic fibrosis? Now this one, to be a son, that's only a 50% chance. So I'll say a half, because it could be a daughter. And cystic fibrosis only occurs 1 out of 4 times with any mating between two heterozygous parents. So the probability that this exact child would be a son with cystic fibrosis, you multiply and you get 1/2 times 1/4 is 1/8. Okay? And then followed by a third child that is a normal daughter. Well, to be a daughter, its probability is a half. And the normal probability is 3/4, because they're not, they're talking about normal phenotype. And there would be 3/4 of the offspring of these parents would have a normal phenotype. So a half times 3/4 is 3/8. You multiply here. All right. So what's the probability of having a son with cystic fibrosis first, 100%, followed by a son with cystic fibrosis. That one's unknown, so that's only a 1/8, followed by a daughter that's normal. That's a 3/8. Okay, so in this case, you would multiply that all up, and you would get 3 out of 64. So when it's straightforward, when the birth order is given, just solve each child separately. Within each child, there were two aspects. There was the gender and then the cystic fibrosis status. And then when you get that all solved, you just multiply across. All right? This is actually more complex than the one I gave you, I think, in the homework. Okay. So, but a couple things that are important. Number one, that the any child that's already born has a probability of 1, because that's already over, that's done. You've seen the child, you know the outcome. And then if the birth order is exact, just figure out the probability of each of them and multiply everything. Okay. All right, so that's 1. I'm going to erase some of this. If I can. Boy, that's a crummy eraser. Let me get a bigger eraser. There we go. I'm going to change the question a little bit because you had a couple of questions on the homework. I'm not giving you the exact ones, but I'm giving you the tools you need to think through them. All right, I'm going to change the question a little bit if I can. Let me get back to this. All right, 2 normal parents have a son with cystic fibrosis. They decide to have more children. I'm going to change it to say, what's the probability that, hang on, that after the birth of their 3rd child, their family consists of 2 sons with cystic fibrosis and a normal daughter. All right, let me get rid of this. Right. So now I changed it a little bit. 2 normal parents have a son with cystic fibrosis, a recessive disorder. They decide to have more children. What's the probability that after the birth of their 3rd child, their family consists of 2 sons with cystic fibrosis and a normal daughter? Now that's, when it says consists of, it's implying the birth order can be any birth order. Now, because they've already told you that the first son has cystic fibrosis, that makes your life a little bit easier. So in this case, what can happen is, what you have to consider is, okay, the first child, why is that gray? The first child has cystic fibrosis, and the chance of that is 100%. So since they already told you that that first son has cystic fibrosis, that's 100%. But in this problem, they're just saying at the end of the day, or at the end of their family forming period, what's the chance that their family will consist of 2 sons with cystic fibrosis and a normal daughter? Well, the first son has to have cystic fibrosis, but they could have the second child could be the normal daughter. I'm just going to put ND. And the 3rd child could be another son with cystic fibrosis. Cystic fibrosis son. That would still fit the description of having a family that consists of 2 sons with cystic fibrosis and 1 normal daughter. But you could also have the first child have cystic fibrosis and be a son. The second child could be another cystic fibrosis son, and the 3rd child could be a normal daughter. So they're not specifying the exact birth order, so this one's a little harder. So we solved this one down here already. We said, okay, it's 100% for the first child to be a cystic fibrosis son. All right, it's, what do we say, 1/8 chance for the second child to be a cystic fibrosis son, and it's a 3/8 chance for this child to be a normal daughter. So the probability of all of this was 3/64, right? But it could also include this up here would also fit the description because the description is more vague, more general. And in this case, this birth order would be a little different. So you have to consider this birth order. This birth order, the normal daughter has a 3/8 chance, and the cystic fibrosis son, third, would have a 1/8 chance. So when you multiply across, you get 3/64. All right. And we are considering either one of these, so we're going to add these two numbers together. So when birth order is not specified, when the exact order of events isn't told to you, when they give you a statement that says you end up with this, combination of results, then you have to figure out all the different ways that you would get any outcome that matches that and add those probabilities together. All right, so in this case, the answer would be 6/64, which I know can be reduced. But so that would be the way you would solve that problem. Because birth order is not given, you have to solve different, in this case, there's two different birth orders, two different families on two parallel universes that would both end up with two sons with CF and one normal daughter, and therefore either one of them being included as fitting the description of a family that consists of two sons with CF and a normal daughter. All right, so that's the end of my tutorial. And be sure to send me questions and continue working on this and talking to each other and talking to me. Thanks, guys.